Sairam everyone. Actually, we are starting with the light. You have got the idea about how we have to proceed it. Okay? So at the end of today's session, that is the first session will be over by now the second session will be over by 12:30. Then probably we'll start at 1:30 and then we will be able to have two more sessions today. So we'll try to cover some portion of it, but there are some prerequisite to that that part which I'm teaching you. Normally what we do after the topic is over, we go for preparation. Am I right? Or before the test, we go for preparation. Am I right? If test takes place after a month, then 29th day, we start preparation. Now, this is the habit that you have to give up. For this topic, the part which we will be completing it today, tomorrow you will be having the oral exam, where I may ask you to stand up and will ask you the question. If you are unable to answer it, I'll give you an additional task of writing down something like 20 times, 50 times, 100 times. Because I am here with a purpose. The purpose is I have been given the most difficult chapter in the syllabus. Other chapters, as you are describing to me that you have covered up to current electricity, or you are talking about the potential and capacitance, the most difficult topic for me to understand is electrostatics. That is charge, electric field, electric potential, capacitance, the most difficult. You can ask me why? Because you cannot sense the charge. You cannot see the charge. Can you see the charge? And the charge which is not seen by us is having an electric field. That is again imaginary. And we are measuring that field which is imaginary. So electrostatic specifically, or the paper 2 side of it, which is comprising of electrostatic, magnetism, electric field, this is similar to that of a blind man on a moonless night searching for his black cat by having a lantern in his hand. The way it is difficult, electrostatics to imagine is more difficult. But once you have understood it, it will give you 100 on 100 in scoring. This is how the topic is there. Ray optics you may find that this is easier to understand, but difficult to score because of the conventions involved in it. Because of how the ray diagrams are to be drawn, how the formulae to be used, what sign conventions are to be used, all these aspects create lot of rules in deriving the formula and getting the correct answer. And that is the reason why I find ray optics difficult in scoring. Ray optics you will always find in NEET examination or any examination, either one or two questions, 100% coming from this area. And that is why we need to prepare this topic more thoroughly. Now, my idea of preparation is very clear. If I am teaching you some concept today and you are 100% preparing it today itself, tomorrow's lecture will be easier for you. Tomorrow's content is prepared 100%, day after tomorrow's lecture will be easier for you. And in that manner, the day I'll be completing the syllabus, you will be prepared from the point of view of content. बात को समझिए, you should be able to understand this. There are different levels of preparation. The first level is understanding. With the help of teacher, you are able to attain that. Second level is practicing the problems or assignments or objective type of questions. That is the second level there. Third level is the testing. If after my teaching you are going to the testing part immediately, it may not work for you. But after assignment or solving number of objectives and questions on ray and optics, you go for a test or an assignment, you will find that there is a benefit for you. So without solving minimum 300 questions as an objective for ray optics, you are not going to master them. Minimum, I am telling you. This is a real trouble for us. Why this is a real trouble? Because we want everything easy. Easy means whatever has been taught, if it is asked in the examination, we are able to perform well. Am I right or wrong? Am I right or wrong? But if something different has been asked, we immediately say, out of syllabus. Right? Nothing is out of syllabus. It's only the approach of the application that is required. And that application skills can be developed only with the practice and not with the help of teaching. Teaching will facilitate you for understanding the application. But practice is the important thing for scoring well. Look, we know very well everything. Are you aware of Shivaji Maharaj? Right? Did he conquer 200 forts in one go? He started winning the forts one after the other. Right? Similarly, in the NEET examination, from the point of view of biology, chemistry and physics, you are having something 28 chapters in physics, almost 28 in chemistry, and around 40. Chemistry 19. So how much is the total? 47. 47 and biology? 32. So if you add 47 and 32, 48 and 32, if I do it, it will be taken as 80. 87 chapters there. 87, right? Now, will you be able to conquer all 87 in the last month? Let us go for 5 days fast, 10 days fast. Will not have anything. You are eating, suppose, 500 gram of rice in the lunch, 500 gram of rice in the dinner, 1 kilogram per day. For 10 days, 10 kilogram. So if I serve you 10 kilogram on a day, will you be able to consume? So my aspect is very clear. Look, we have started with ray optics. Swamiji wanted me to deliver it to you. I am ready here. I am coming from a long way from central India only to help you out on the ray optics part. That Swamiji's wish that we should be able to show that this works for all of us. Am I right? Am I right or not? So I want that particular discipline, whatever had been taught is immediately prepared by you. Okay? Are you getting this? We'll start. Now have you got the point clearly? Okay. Now, so we have started with a light. So can anyone now elaborate what is light? Light is a form of energy that we have already stated. Any other way we can explain light? Come on, I want everyone's participation to the greatest extent. Anyone who can tell me? What is light? Say, let it be wrong, no problem. Yes? Light is a? Very good. You can look upon light as a wave also. Am I right or wrong? So light can be chalked off as an energy. What is the use of this energy? What is the use of light as a wave? Obviously, everyone knows that light is an energy, light is a wave. Can I say that light is a ray? We use it word ray of light. So can I say light is a ray? Can I say that? So what is the use of ray? Light travels in a straight line. That is, light ray travels in a straight line, or light as a wave travels in a straight line? Wave do not travel straight line. Why do you think like that? Yes, rightly pointed. Very good. Rightly pointed. It's a wave. Are you getting this part? So does it not mean that it is traveling in a straight line? Something that is moving in this manner is not traveling in a straight line. Now there are different aspects in it. Light is energy, light is a wave, light is a ray. All these things we are defining. But why we are having the definition for the light? Light is energy. What is the use of this energy? Yes? Yes, very true. Light is that form of energy by which we are able to see the objects. So what are the things required to see the object? Light is required. Eyes are also required. And object is also required. Eyes are required or not? So light is there, object is there, but eyes are not there. Will you be able to see the object? So you require three things. What are those three things? Light is required, object is required, as well as eyes are required. Now why we are able to see the object? It reflects. What is that it? Light reflects light. Object. That is more correct. So you should not talk in terms of it. You should say that object reflects the light. Why the object is reflecting the light? Its property to reflect. If object is reflecting the light, then why it is not behaving like a mirror? How can you say that it is an irregular reflection? A wall is a smooth one. A wall is properly, smoothly polished here or painted here. How can you say that reflection in this case is irregular? It is not completely reflected. Means what? Not particularly directed in one direction. Do you mean to say that it do not obey the laws of reflection? Then why it is not particularly reflected? Why the reflections are not parallel? Very good. See. So whenever a light falls on the body, it 100% do not reflect. It reflects partly. Some part of energy is absorbed by the object, remaining part is reflected or it is even transmitted. Like this is a class. If someone stands outside the room, we are able to see him because the light is passing through the glass reaching to me. So obviously there is a transmission also that is taking place. We call it as transmission of light. Some light will be getting absorbed, some will be reflected, some will be transmitted. So that is how there is a distribution of energy when we are looking at it. So this part is nothing but the conservation of energy. Am I right or not? Suppose the light is incident on the object, some part is reflected, some is absorbed and some is transmitted, then the total sum that is incident is distributed in the form of absorption, reflection, transmission. Irregular surface will be reflecting irregularly, but polished plain surface will be reflecting regularly. Are you getting my point here? Suppose it is an irregular surface. It is having lot of smoothness and roughness involved in it. Both the things are present there. Then reflection will not be orderly. It will be disorderly reflection. If there is a disordered reflection, it would mean that it is similar to that of scattering of light. Similar बोल रहा हूँ. You have to understand the term. It is similar to that of scattering. But light is getting reflected in an ordered manner. It means that all the rays are incident parallel to one another. Then all the rays will be reflected parallel to one another. We call it as reflection, ordered reflection or regular reflection. Have you got this part clearly? So light is the energy, light is a wave. Now the question should come to your mind that why we are calling light as a wave. Anyone who can help me out? Why we are calling light as a wave? Anyone? Any scientist who have given the theory that light is a wave, why he is thinking of light as a wave? Light consists of particles? No. What is a photon? Yep. Small. Where has been this packaging done? It's a fixed amount of energy. You call it as a photon. When it is a packet of energy, why would you like to call it as a particle? Is energy a particle? Is energy a particle? Come on, answer this. Is energy a particle? Then you are calling the packet of energy as a particle and energy itself not a particle. So what is a photon? A packet of energy. Energy is not a particle, but packet of energy is a particle. What a confusion. That is why I am asking you, what do you mean by photon? Am I right or wrong? Look, what is the basis of my lecture? I am not talking about the content. But good answer. Light is a wave, but does it require a material medium for propagation? It can travel through vacuum. Then so actually what is happening, you have to understand, all of you have to understand me clearly. Whenever I am asking something, I am referring to my questioning skill. And I want to build in you the questioning skill. That is why I told you, the moment you hear the question, note it down. Have I said it or not? Even if you hear from someone else, note it down. Questionings are extremely important. That makes us think. So I started with the question only, right? And what you started responding to that, what you have done, you started using some new words. The moment someone said that light is the energy, another corner, the student said light is a wave. Then I added to it that light is a ray. What is, after looking at these three statements, what do you think? Which one is the most correct? Most correct, I said. I said most correct. Light is a wave is most correct. You change the answer. I don't have problem by you are changing the answer. If you change the answer and change the expression, you will change the answer. Light is energy. Now the way I am saying it to you, light is the energy. No, it cannot be energy. Change it to wave. The moment you say wave, no, it cannot be. It's a particle, 100% a particle. How it can be a particle? Sir, photon, new name for it, photon. What is photon? Some other name, packet of energy. How a packet of energy can be a particle? Is energy a particle? No, it cannot be. Something else. What we are doing, I'm just triggering your thoughts in your mind and you are speaking up without understanding. Let it come out. Bahar aa jaane do. Let it come out. Because unless and until it comes out, the slate will not be cleared and the thoughts will not be properly organized. Have you understood me? Now, this is how we have to analyze it. So, first important thing, I am having three statements. Light is a wave, light is a energy, light is a ray. Which of them is the most correct? Why do you think that light is energy? So, tell me, any one of you, please tell me, have you talked of light in terms of joule? Have you talked of light in terms of joule? Yes or no? Oh. So you say loudly, when I was a student of your age, I used to play with this, with the teachers like this only. Teacher used to ask, what is this? Yes or no? I should say, no. Then teacher themselves used to make a statement, how it can be no? I said, ho. Like sometime before, somebody nodded the head in this manner. I was observing everyone because he was saying no but nodding the head in this manner. So you need to be a good observer also, na? Then only you can enjoy the part. Isliye I am asking you again, light is an energy, important, light is a wave, important. And if light is an energy, have you expressed light in terms of joule? The moment you say that you have never expressed the light in terms of joule, it means that light is not the energy because unit of energy is joule. So have you expressed light in terms of joule? हाँ sir, हाँ. अरे नहीं क्या बोल रहे हो? No, I am saying हाँ. Okay, so anyone? So have you purchased incandescent bulb? How do you purchase it? दुकानदार के पास जाते हैं. How do you purchase from the shopkeeper? Only paying the money. He is having only one type of bulb at his place. Incandescent bulb एक ही type का होता है. So what is that? What is power? You are saying to me, no, we are not expressing light in the form of joule. And you are going to purchase a bulb from a shopkeeper by telling the wattage. 100 watt चाहिए, 12 watt चाहिए, 15 watt चाहिए, 18 watt चाहिए. What is that? It's a power. Now actually we talk in terms of electrical power getting converted into the light energy. Am I right or wrong? So are we expressing light in terms of joule, yes or no? But I was aware of the fact that nobody had ever tried to think in this manner, and that is why everyone started feeling for a moment, no, we never talk of light in terms of energy. Joule, kabhi nahi. Are you understanding my point? So we talk in terms of energy, we talk in terms of joule about the light. Light is a form of energy, that is sure. Have you studied anything similar to that of light? Sound. I was telling you the same part. I am able to listen you. Sound. So sound is energy. Then how does the sound propagate? In the form of wave. So how, if sound is an energy and it propagates in the form of wave, then light is also the energy. How will it propagate? That is the reason we have concluded that light is a wave. Because our reference point is sound, sound is an energy and it propagates in the form of the wave. So light is also the form of the energy, it will propagate in the form of a wave. Have you heard nowadays, some few days back, the meteorological department has given orange alert for some places across India where they will be having the heat wave. Have you heard of heat wave? Actually, last week of month of May, we are having 9 days. We call it as Nautapa. The last 9 days of the month of May are going to have a large amount of heat. We call it as Nautapa, and in that 9 days you are having lot of heat there. There is a heat wave. What do you mean by wave? What is heat? Energy. Now if heat is energy, again we are associating energy with the wave. Propagation of heat energy in the form of wave is there, we call it as a heat energy or heat wave. So whenever the word energy comes there, we talk about the wave. Propagation is always in the form of a wave. If this is so, then why we are considering light as a ray? Light travels in a straight line? Sure? It's not about the topic. You have to prove it that light travels in a straight line. How will you prove? How will you prove that light travels in a straight line? So this is a perception that everyone had, that light travels in a straight line, therefore light is a ray. Can anyone show here that there is a light? In this room, can anyone show me that there is a light? You should say that, sir, your question is wrong. But I already explained to you, no question in the world is wrong. Are you able to see the light here? नहीं है light? So you are able to see the object, therefore the light is there. So for a blind person, he is unable to see the object, he doesn't have any sensation of light. अरे सही तो है. If a blind person is unable to see anything in the world, will he be able to sense the light? Never. So 3 things are required. That was our first point. Light, eyes as well as object. Right? My point is very clear here. When we are making a statement about the ray of light, looking at that the light travels in a straight line, therefore light should be a ray, and you are able to see a light here, can anyone here show me the ray? Sir? That is not a ray. That is why the question is extremely important, that why we are thinking of ray of light. Look, this is the part which you should understand. Illumination is a word. I don't know whether you have heard this word or not. Illumination. Now here you are able to see a greater illumination as compared to the back. Because at the back the lights are off. You can check it out. The difference in the intensity is there. Here on this side the intensity is more. There is more illuminati, or you can say that there is more illumination. Am I right? So intensity of light is more in this particular area as compared to the back where the intensity of light is less. So there is a luminosity here. So we call it as illumination. The problem is we can never see a light traveling from source to the destination. Nobody can see it. Can you see the light traveling in the wavy manner? Can you see the light traveling in a straight line? Never. Then why you are thinking of ray of light? Are you getting my question? The answer is very clear. Ray of light denotes the direction of propagation of energy. Ray of light denotes the direction of propagation of energy. Ray of light denotes the direction of propagation of energy. That how that energy is traveling from point to point, in what direction the energy is traveling, that is pointed out by the ray of light. It is the part of a wave only. Rather, it is a normal drawn to the wave that describes the ray of light. Normal drawn to the wave describes the ray of light. It's a normal, and that normal is telling you about the direction of propagation. Any wave, you put a normal on it, you will be able to get the direction of propagation. And that direction of propagation, we represent it by a ray of light. Have you understood the terms now? So light is a form of energy. Every energy will be having the wave nature. So it will be traveling in terms of wave. Are you clear with this idea? Are you all clear? Now when we are talking of light as a wave, what are the physical quantities associated with it? What are the physical quantities associated with the light as a wave? Yes? Very good. So the first term that we will be coming across here is a wavelength. लाइट के साथ ये वर्ड हमेशा रहता है. Always you will find the word wavelength associated with the word wave. Anything else? Correct. The second term that you always talk about wavelength, after the wavelength, is that of frequency. Any other term you talk about? Yes? Amplitude. So third term that you are talking about, we are calling it as amplitude. Fourth term. Yes? Okay, you talk about the term that is known as wave number. Anything else? You said it, that is correct. Velocity. Or intensity, you want to add it. This is similar to that of throwing the stone. पत्थर मार के देख लिया, लग गया तो आई एम जीनियस, नहीं लगा तो आई एम नॉट जीनियस. I'm just picking up the stone and throwing it. Don't be of that type. Anything else? Sure. Are we using it? Okay. Correct. Time period is there because it's related some way to the frequency. So I'll put it down in front of it. I'll call it as seventh time period. Very good. This was expected. That is the phase. Then anything else? Anything else? Anything else? नहीं? नहीं? Very good. Say it loudly. Very good. K is taken as equal to 2 pi upon lambda, that is called as propagation constant. Anything else? Any other quantity associated with the wave? I'm sure you have studied it. Because you are able to connect with this physical quantity, that physical quantity, you have studied it. Think. 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 W. What is omega? Angular. So you are having this quantity again associated with the wave. We are calling it as angular velocity. Anything else? Last chapter of 11th standard. Oscillation and waves. Have you studied about it? All these quantities written on the board are coming from the same chapter of oscillation and waves. Have you studied about it? Not studied? Means what? Means the teacher entered the class and said OSC. I'll not teach oscillation completely, I'm only teaching you OSC. आपने नहीं पढ़ा है या टीचर ने नहीं पढ़ा है? Waves not there. Oh, waves have not been completed. Why so? I'm asking you just for the information sake. Exams में नहीं है. Oh, that is the reason that part was skipped out. Okay, no problem. Now, actually, the idea is very important. These physical quantities must be known to all of you. We'll start with wavelength. So, can anyone explain me wavelength? One by one, please. Crest and trough. And or. So the first definition that is coming to me is distance between the two successive crest or two successive trough. We call it as a wavelength. Are you all aware? So as per the definition, let us put down the wave in this manner. So which are crest and which are trough? This is called as crest and these are called as trough. So according to the definition, this distance or this distance is to be taken as wavelength? Why downward? जब आपका वेव ऐसे ऐसे जा रहा है तो आप ऐसा डिस्टेंस ले रहे हो. वेवलेंथ किसे बोलना है? When your wave is traveling in this manner, distance between two trough is taken from here to here or here to here. Why you are taking this distance? Come on, tell me clearly. No, I am telling you one important point here. How many of you, when you heard the definition, thought of this distance at some moment of time being the part of the wave? Or you are told that this is the straight line distance that is only to be taken, but why didn't you ask them why? Yeah? Okay, so what will be the other form of definition there? Between same phase. Same phase means phase difference will be 0. And when you say that the phase is same, phase difference is 0, the point is same. When you say same phase, it means that on this axis we are taking here the phase and here we are taking here displacement. So when you say same phase, so I'll be able to mark a point here. This point will be having the same phase. If you take the two different points on the wave, then there will be a phase difference. So if you are talking of a same phase or phase difference equal to 0, the length will be 0 then. Are you getting my point? Then say it. Two successive phase. But what is phase then? Phase is the angle. So distance between two successive phase differing by 1 degree. Distance between two successive phase which are differing by 2 degree, 3 degree, 90 degree. You have to define the degree then. Look, I'll tell you what has happened with me. That is the best way to put down the things before you. Now, there is an important part that everyone should understand me clearly. All these things have appeared in my mind before when the teachers were teaching me. When teacher told me that distance between the two successive trough is to be taken as wavelength, this line is lambda, I asked them, why not this? Because it's a distance. Are you saying displacement or a distance? You are saying distance. So why that straight line distance has been measured, nobody had explained me. But I had in my mind that why this distance is not covered between trough to trough. I had this question in my mind. My teachers did not answer me. Similarly, whatever you are trying to put it down as a phase relationship, you are missing some point. That is why I am able to question you again to confuse you. My job is very simple. Whatever you say, I'll make you confused and you will forget about it. So such a simple job I am having. But this is some or the other time will make you understand the importance of words. Whatever you are saying or whatever you are saying is correct, but the words are not correct. I have understood what you have said. Only framing of words should have been done in a proper manner. You could have got the meaning correctly. I'll show you how. Now this distance we are covering it as lambda. I'll explain you why not the curved part. This distance here you are calling it as wavelength lambda. From here this distance you can call it as wavelength lambda. Barabar hai? Now if you look at the phase, you will be able to say that this is zero phase. This is a phase which is called as pi by 2. This is pi. Then you are having here 3 pi by 2. Then you will be having 2 pi, 5 pi by 2. Then you will be having 3 pi. Then you will be having 7 pi by 2. Then you will be having 4 pi. And finally you will be having here 9 pi by 2 and 5 pi. This is how phase is given in terms of pi. Am I right? Am I right? Yes or no? Have you got it or not? Okay. Now, if you consider this crest is having the value at pi by 2, this crest is having the value at 5 pi by 2. So, the phase difference between the 2 points 5 by 2 minus pi by 2 will be equal to 4 pi by 2, that is equal to 2 pi. If you take the trough, this trough is at 3 pi by 2. So you will be having this trough as 7 pi by 2. So you will be having here 7 pi by 2 minus of 3 pi by 2, that is equal to 4 pi by 2, that is equal to 2 pi. Am I right? Am I right or not? You consider this crest, this is 9 pi by 2 minus of 5 pi by 2. So you will be again having 4 pi by 2, that is equal to 2 pi. So when you are measuring the distance between the two successive crests, because two successive crests are differing by 2 pi radian, or two successive trough, because those two successive trough are also differing by 2 pi radian. So, in your words, what the definition should have been? The distance between two successive points on a wave which differ in phase by 2 pi radian, you are calling it as wavelength. Am I right or not? Any 2 points on a wave which differ in phase by 2 pi radian will be called as a wavelength. That is the second way of giving the definition of wavelength. So second way of giving the definition of wavelength means any 2 points. Suppose I am having some other color used there so that I can mark that part. Suppose I am taking this point here and corresponding point here, then these 2 points are differing in phase by 2 pi radian, you will be marking this as wavelength. You can take this point here and corresponding point at this particular part, then this distance can also be taken as equal to wavelength. So पहला definition ये था, the distance between the two successive points, two successive crest or two successive trough, you are calling it as a wavelength. The second approach we are putting it, the distance between any two successive points on a wave which differs in phase by 2 pi radian, you are calling it as a wavelength. The distance between any 2 points on a wave which differs in phase by 2 pi radian, you are calling it as a wavelength. Have you got it? Clear? Hai? Sure? So two definitions are clear. There is a third definition, and which is the most simplest one, not taught to the student, not mentioned in the textbook. Can you explain that? at the end when I will disclose that definition to you, next time anyone asks you what is a wavelength, you will give the third definition, none of the first and second definitions. Should I tell you? Don't forget about my Guru Dakshina. That is always there. So, what we have to define here? Wavelength. So, wavelength is a length of a wave. Now tell me which is the easiest one. Third one is easiest. That is why Newton's third law is also easiest. Whatever comes third is the easiest one. Is it wrong? Or do you agree that this is the simplest and the easiest one? What is wavelength? Length of a wave is called as a wavelength. But we have to verify whether it is correct or not. If it is verified, then only we can accept it. So can anyone help me in verifying it? That wavelength is the length of the wave? Obviously, length of a wave is the length of one wave. Can you verify it?
One wave means one transmitted, one transmitted. And if we add both, it will give two by two.
Look at this point. This is 2 pi. This is 0. So there is a difference in phase between these 2 points that is of 2 pi corresponds to the wavelength. So as per the second definition, any 2 points on a wave which differs in phase by 2 pi radian, you are calling it as a wavelength. So the first point on a wave here is having the phase 0. The last point on the first wave, this is one wave completed here, will be having the last point, phase will be 2 pi. So difference between 2 pi and 0 will be 2 pi. So the 2 points on a wave which differs in phase by 2 pi radian, you are calling it as wavelength. So this is length of one wave, that is from here to here, that you are calling it as wavelength. Am I right or wrong? Do you agree with me? You have doubt. You always calculate the phase difference between the 2 points. Like the crest is here at pi by 2 and you are having the crest another at 5 pi by 2. So what is the phase difference between these two crests? 2 pi. So consider this one point on the wave, its phase is 0. The last point on the wave is here. Its phase is 2 pi. So what is the phase difference between the 2 points? So any 2 points on a wave which differs in phase by 2 pi radian, you call it as a wavelength. The same thing. Now out of the 3 definition, which is the most important definition then? Second is the most important. Then why we are talking about the successive crest and successive trough? Am I right or wrong? Why are we talking about the successive crest and successive trough? No, we have understood that successive crest differs in phase by 2 pi radian, so the distance between two successive crests is called as wavelength. The successive troughs which also differ in phase by 2 pi radian, so that distance is also called as wavelength, right? That is true. But in the first definition we say that crest and trough, as per the second definition, any 2 points on the curve on the wave which differs in phase by 2 pi radian, we are calling it as a wavelength. That is true, there is no doubt about it. But then why we are defining first the distance between the two successive crest and two successive trough only? Nobody tells us about the second definition or the third definition, whereas third definition is the most easiest one. Length of one wave is called as a wavelength. Right? So why we are defining in successive crest and trough terms? So answer is very clear. I have told you the concept of light has been evolved from sound. Am I right? Sound is the energy, sound propagates in the form of the wave. Light is the energy, light propagates in the form of the wave. I have told you this part. Right? Now, have you ever dropped a stone on the surface of the water? What you are able to see? Stone. What you are able to see? You are able to see the waves in this manner. You have never dropped a stone on the water then. You are able to see the concentric circles moving towards the center. Concentric circles you are able to see in the first go. Drop the stone, concentric circles. Like this. A stone is dropped, first wave is created. That first wave is circular in nature, travels towards the boundary. After some time, at the center, the second wave is getting created. The second wave is following the first wave. First wave propagate, the second wave also expand. First wave is also propagating, expanding. Second wave is propagating. Then after certain distance, the third wave is getting created. And then you are able to see the concentric circles. Am I right or wrong? Or is it like that you have dropped the stone and three circles are immediately seen? They take place one after the other, successively. Am I right? But still, I have not got the answer what you are able to see. You never see a trough whenever you are dropping a stone on the surface of the water. You only see the crest, the upper part. And that crest is only traveling. Troughs are not seen because the water medium is able to replace the trough immediately as soon as it begins to travel on the surface of the water. So the distance between the two successive points or the waves can be directly measured by taking the distance there, and that is representing the wavelength. So as you drop the stone, you are able to see the first wave traveling, the second wave is getting evolved. You measure directly the distance between the two crests, you are able to talk about the wavelength of the wave generated. Because crests are only seen, trough are not seen. Even though the vibrations are taking place in a sinusoidal manner, 2 points having the same phase cannot be identified. But crest is a unique point of a wave. मैंने क्या बोला समझ में आ रहा है क्या? देखो आप. You should understand what I am saying. Crest is a unique point. Why I am saying crest is a unique point? You can see and observe here. Suppose I am able to mark this point. Then there will be equivalent point here also. There will be equivalent point at this part also. For a crest, there are 2 points having the equal displacement. But for a crest here, it is a singular point. In a complete wave, crest and trough are only 1 points. For all other points, there are pair of points there. Are you able to see that? Are you able to see that, or yes or no? And that is why distance between two successive crests had been set there. Two successive trough had been set there because crest and trough are unique points of the wave. Have you got why that definition is coming in terms of successive crest and successive trough? Have you got it clearly? So this is about the wavelength. Now you are having here propagation constant. The formula is given to you, 2 pi upon lambda. Right? What do you mean by propagation constant? What will be the unit of propagation constant? No. Radian is a supplementary unit. So we never talk about the radian. It is only taken in per meter. Right? It will be inverse of a meter or meter inverse we can say. Right? So it is a propagation constant. It tells you about how the phase of 2 pi is going to change in a 1 meter distance. Are you able to get what is propagation constant? It is going to tell you about how the phase of 2 pi is going to change in 1 meter distance. That is why we call it as a propagation constant. It is related to the wavelength. Okay? Then you are having here frequency. What do you mean by frequency? Frequency? Very good. So number of waves passing per unit time, you are calling it as a frequency. Time period? Or time taken by one wave to pass through it is called as time period. In 1 second, how many number of waves are passed is the wave frequency. Because number of waves per unit time. Right? So when you are taking the reciprocal of it, time upon number of waves, so it is a time taken for one wave to pass a given point on a medium, you are calling it as a time period. Able to get me? I'll repeat it once again. Frequency is the number of waves passing per unit time through a given point of the medium. Frequency is the number of waves passing per unit time through the given point of the medium. That is called frequency. The the time over number of waves, that is giving you time period. So time period is the time taken by one wave to pass through the given point of the medium, that is called the periodic time. इसको आप ऐसे भी ख्याल में रख सकते हो. You can use here frequency, that is reciprocal of time period. Frequency is taken as number of waves per unit time, and time period will be taken as time divided by number of waves. So I think you are getting it clearly now. Okay. What is amplitude? Height of the crest, or okay. Then wave number. Loudly. Number of Number of complete wavelengths you are saying. No, actually it is not. Number of complete wavelength can be anything. But you have to define, add to it something. It is the number of wavelengths present in 1 meter distance, that is wave number. Because if you take more and more distance, the number would go on changing. Wave number is the reciprocal of wavelength. Wave number is taken as 1 upon lambda. So in 1 meter distance, how many wavelengths are present? You are calling it as a wave number. In 1 meter distance, how many number of waves are present? In 1 centimeter distance, how many number of waves are present? In 1 millimeter distance, how many number of waves are present? So anyone who is aware of wavelength of yellow light? Yellow light का wavelength किसी को पता है? Okay, we'll take it as simple example. Kilogram लिख दूं? So who is going to say that? That is why I said it kilogram. 600 nanometer. I have no problem. We can go for it, or we can take it as the wavelength will be taken as 6000 Armstrong unit or 600 nanometer. Right? So wave number will be taken as 1 upon lambda, that will be equal to 1 upon 6 into 10 to the power minus 7. This will be expressed in terms of meter inverse. It means that 1 by 6, how much it will be? 0.166. So it will be 1.66 into 10 to the power minus 8 plus, this is minus 7 going up. So it will be plus 7 and point. Plus 8 आएगा यहाँ पर? Sorry, plus 6. बराबर है? अब इतने number of waves, this many number of waves are present in 1 meter distance. Now you can look at it, 10 to the power 6. 10 to the power 6 and how much it is? 1 million? 10 to the power 6, can I say 1 million? So it is containing 1.66 million waves present in 1 meter distance. So if you divide it by 100, you will be having 1.66 into 10 to the power 4 per centimeter. यानी you will be having 10 to the power 4 से multiply करना है तो 1, 2, 3, 4.66. This many number of waves. This many number of waves are present in 1 centimeter distance. So if you consider the yellow light to have a 5000 Armstrong unit or 6000 Armstrong unit as a wavelength, 6000 is for a blue color. So blue color की अगर हम बात करते हैं 600 nanometer की, तो वहां पर you will be able to have 16,666 waves present in 1 centimeter distance. So if you want to calculate in 1 millimeter distance, it will be 1666.66 waves present in a millimeter distance. 1666. Now you can take a scale, see how big the 1 millimeter distance is, and imagine that it is containing 1666 waves. And this is the reason why we think of straight line. Your perception was that it is a ray of light, that is why it is traveling in a straight line, is not correct. As the wavelengths are extremely small, you can check it out, 1 millimeter distance on a scale, that will be containing 1666.66 waves. 1600. अगर वो 1 millimeter distance, if you are dividing into 1600 part, then it will be the wavelength of one wave. It's such a small wavelength that it appears to us to be traveling in a straight line. Are you understanding this part? It's such a small distance, it will appear to you to be traveling in a straight line. I'm drawing this particular figure. Tell me, is it a curve or a straight line? But on this curve, if I consider a very small distance, so our waves are curved one only, but their wavelengths are so small that we take it as a straight line. Have you got it? We will continue the discussion. This is not over. We'll take some time because we have started the light and the wave. We need to understand it. And as you have said that we have not represented the wave mathematically, I'll show you that part and proceed ahead. Okay? So we will just move on with these concepts ahead. See you. Sai Ram.